You know the scene, right? That classic movie moment, a giant spaceship explodes in this huge, fiery, booming spectacle. It looks incredible. But here's the thing. It's totally, completely wrong. The real cosmos is way, way quieter. So in this explainer, we're going to dig into exactly why that is. So here's how we're going to break it down. First, we'll separate that Hollywood fiction from the real scientific facts. Then we're diving straight into the physics of how sound actually works. After that, we'll take a trip into the vast, empty vacuum of space. And then, this is the cool part, we'll see how scientists have found clever ways to listen to the universe anyway. And finally, we'll wrap up by thinking about what all this silence really teaches us. All right, so this is where it all begins, right? In that huge gap between what we see on screen and what an astronaut would actually experience. It's really a classic case of Hollywood's need for drama, bumping right up against the fundamental laws of physics. And yeah, this really gets to the core of the whole question. I mean, we've been basically trained by movies to expect this massive, deafening roar. So what gives? How can something like a supernova, an explosion so incredibly powerful it can outshine an entire galaxy, happen in just total, absolute silence? Well, the hint isn't that it's just for dramatic effect. I mean, sure, filmmakers add it for the drama, but the real reason for the silence? It's not a creative choice at all. It's pure physics. And to get why, we've got to take a closer look at what sound even is. Okay, so how does sound actually work? Let's get into the nitty-gritty here. What is sound? And maybe more importantly, what does it need to even exist in the first place? So here's the absolute key idea. Sound is a mechanical wave. Think of it like ripples in a pond, or maybe even better, like a line of dominoes falling. It needs a physical something, particles, to actually carry its energy from one place to another. If you don't have that medium to travel through, you get no sound. End of story. Just think about what happens when you talk. Your vocal cords vibrate, right? Well, that vibration creates this pressure wave in the air around you. It's kind of like a tiny invisible traffic jam of air molecules, all bumping into each other. This chain reaction keeps going, particle to particle, until it reaches someone's ear, and bam, their brain translates that vibration into what we call sound. Now let's compare that to light, because light plays by a totally different set of rules. Light is an electromagnetic wave. What does that mean? It means it doesn't need any particles to travel. It can just zip right through a perfect vacuum all by itself. And that right there is the fundamental reason we can see a star billions of light years away, but we'll never ever be able to hear it. And that brings us perfectly to the main culprit behind all this cosmic silence, the vacuum of space. And when I say empty, I don't just mean a little bit empty. It is profoundly, mind-bogglingly empty on a scale that's almost impossible to wrap your head around. Okay, let's try to put this into perspective. Imagine a little box, about the size of a sugar cube, filled with the air around you right now. Inside that tiny space, there are roughly 25 quintillion molecules. I mean, that is just a massive, bustling crowd of particles, all jammed together, ready and waiting to pass a sound wave along. Okay, now let's take that exact same sugar cube and teleport it out into deep space, between the galaxies. In that same little box, you would be lucky, really lucky, to find even a single atom. There's just nothing. There's nothing there for a sound wave to push on. The line of dominoes we talked about, it's missing pretty much all of the dominoes. I mean, look at that difference. The density gap is just staggering. It's almost comical. Compared to our atmosphere, space is, for all intents and purposes, a perfect vacuum. So any vibration from an exploding star, no matter how powerful, just fizzles out into nothing. There's simply no medium to carry it anywhere. And this isn't just some abstract theory, Astronauts who go on spacewalks, they report this firsthand. Inside their helmet, sure, they can hear themselves breathing, the hum of all their equipment. But outside of that little bubble, there is a silence so total, so complete, that they say it can be really disorienting. It's a powerful, powerful reminder of just how alien that environment is. So, okay, space is silent. Case closed, right? Well, not quite. Because here's where things get really interesting. While the universe doesn't make sound in the way we think of it, it is absolutely buzzing with other kinds of energy. And incredibly, scientists have figured out how to translate all that cosmic activity into something we can actually listen to. This amazing process has a name. It's called sonification. And you can think of it like this. You know how we make charts and graphs to visualize data? Well, this is basically the same idea, but for your ears. Scientists take data from stuff like plasma waves or radio emissions, signals that are totally silent to us, and they map their frequencies and their strengths into sounds that we can actually hear. And the results are just haunting, and sometimes really beautiful. That constant stream of particles flowing from our sun, the solar wind, it gets turned into a kind of high-pitched whistle. The massive magnetic field around Jupiter creates these weird rhythmic pulses and tones. And the crazy storms on Saturn, they're translated into these deep, swooshing rumbles. Now, to be clear, these aren't the sounds you'd hear if you were actually there. But they are the authentic voice of the powerful energies that are shaping our solar system. So once you start to really understand this cosmic silence, it takes you beyond just the physics of it all. It actually starts to change the way you think about the universe and our place in it. I mean, really think about it for a second. The quiet of the cosmos isn't just an empty void. It's a fundamental characteristic of our universe. And that has huge implications for science, for philosophy, and even for the psychology of the people who are brave enough to actually go out there and travel through it. So, what are the big lessons here? What does all this silence teach us? Well, for one, it's a huge reminder that our human senses can only pick up on a tiny, tiny fraction of what's really going on. That very fact is what drives us to build incredible tools, like radio telescopes to help us hear the invisible. It definitely inspires a sense of awe. And on a very practical level, it helps us understand the immense psychological challenge that astronauts face, living and working in that vast, quiet emptiness. So, it all leaves you with this one last big question. If we know the universe is just full of energy and information that we can't perceive directly, and we've already figured out how to turn something like plasma waves into sound, well, what else are we not hearing? What other cosmic languages are out there, just waiting for us to build the right translator to listen in?